In this video, we'll learn how to differentiate functions which have negative powers of x inside of them. Now, the first thing we need to do here is remind ourselves of a formula we learned in algebra. Anything looking like a over x to the power of n is equal to a times x to the power of negative n. So in fact, I'll go ahead and box that result. You want to make a note of this. This is a very important result. Now, let's look at a couple of examples of what this is actually saying. Example, let's say we had to write 2 over x cubed as a simple power of x. Then we would write, using this formula, that that's 2 times x to the power of negative 3. Another example could be if I had 4 over x. Well, first of all, it's important to realize that this means 4 over x to the power of 1, and therefore we can write this as 4 times x to the negative 1. Now, keeping this formula in mind, and what we've learned about differentiating powers of x, we're going to be able to differentiate any function looking like f of x equals to, say, 2 over x plus x squared, for instance. By the end of this tutorial, we'll know how to do that as well. So let's get started. Let's say we have to differentiate this function. And I'll call this example 1. Well, the first thing we do is rewrite this function without any x's on the denominators. So using what we just learned, we can see that 2 over x can be written as 2 times x to the power of negative 1 plus x squared. Now we can use our method for differentiating powers of x to differentiate this function. And we can go ahead and say that f dash of x, the derivative, will equal to negative 1 times 2 times x to the power of negative 1 minus 1 plus 2 times x to the power of 2 minus 1. This leads us to f dash of x equals to negative 2 times x to the power of negative 2 plus 2 times x to the power of 1. And finally, we could write f dash of x equals to negative 2 times x to the power of negative 2 plus 2x. And that would be our answer. Let's look at another example. I'll say example 2. Let's say we have to differentiate y equals to 3 over x squared plus 4x to the power of 5. Well, in this case, we're going to start again by rewriting this function so that there are no x's on the denominators. And so we can go ahead and write y equals to 3 times x to the power of negative 2 plus 4x to the power of 5. We can now differentiate this using the same method as always. And we can go ahead and state that dy dx will equal to negative 2 times 3 times x to the power of negative 2 minus 1 plus 5 times 4 times x to the power of 5 minus 1. This leads us to negative 6 times x to the power of negative 3 plus 5 times 4, which is 20, x to the power of 4. And there we go. That's how we can deal with functions with negative exponents.